Hey guys, in this video, we're going to be talking about multiplying rational numbers, right? So what are rational numbers? We learned that in the last video, link in the iCard. We are talking about multiplying fractions, right? Because rational numbers are anything that can be written as a fraction. So we're going to focus kind of on two different things. One is I'm going to stress, and this is actually for way in the future in this course and in your math life and all of those things. And that's that when you multiply fractions, you just multiply straight across, easy peasy. You don't need a common denominator or anything. We'll talk about that later when we're adding and subtracting them. And we're also going to kind of take a bit to focus on pre-reducing, because that's going to make our life much, much easier. Let's dive in and see what I'm talking about. So we're going to do a problem. We're going to do this first one twice. Okay, this one actually isn't necessarily the best example of this, but it gets the point across kind of simply and straightforwardly, right, and all that kind of stuff. So let's do some examples. Example number 1. We're going to multiply 1/6 times 2/3. So what was the first thing I said? We multiply fractions, we do it straight across, right? 1 times 2 is 2, right? And then 6 times 3 is 18, right? So 1/2 times, 1/6 times 2/3. I hate the word sixths. It's terrible. I know, I said that in the last video. Every time I say sixth, I'm liable to say it because it really does bug me and twist my tongue all up. Sixth. Terrible. Okay. And so then the important thing to know is we've got to reduce, right? We don't want to leave this unreduced, so we're going to divide the top and bottom by 2. Okay. So 2 divided by 2 is 1. 18 divided by 2 is 9. That's not too bad. On this particular problem, admittedly, that's not that bad. Now, if we end up with big old huge numbers, it is so much easier if we take the time to pre-reduce. Even on this one, it's easier in a way, right? Because we don't have to go into double digits. So I'm going to rewrite this problem again. 1/6 times 2/3. So if we're thinking about pre-reducing, we're looking at the tops, so these guys, and the bottoms, so those guys, right? And they can be straight, one on top of each other, or diagonal. And a lot of times we're looking at diagonal. So we can't reduce 1/6, and we can't reduce 2/3, but we can reduce 2/6, because those are both divisible by 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. Once we've pre-reduced as far as we can go, then we can just multiply the tops together and multiply the bottoms together. 1 times 1 is 1. 3 times 3 is 9. Easy peasy. I do, by the way, have an entire video on this topic. It's an older video. I can't vouch for the quality. It's probably decent, though. The audio is at least good, and I think I did the video as me actually handwriting, but I'll put the link to that in the iCard if you want to spend some more time on pre-reducing. I have a whole video basically on that topic. Yeah, so you can check that out if you need to. Let's do a second example. Example number 2. Whoa, that was exciting. I tried to be clever, but it didn't work out. Let's do example number 2. 3/4 times negative 7/9. Now, we multiply positives and negatives. All the rules that apply to integers still apply to rational numbers. So if we're multiplying numbers with different signs, then our answer comes out negative. So we're ultimately going to get a negative. Now we want to look and see if we can pre-reduce. So does 3/4 reduce? No. Does 7/9 reduce? No. Does 7 and 4 reduce? No. but 3 and 9 does, in fact, reduce. They reduce by 3 because 3 divided by 3 is 1. 9 divided by 3 is 3. That's easy peasy. Another nice thing about pre-reducing is if you pre-reduce all the way, then you know your answer is reduced all the way, and you don't have to worry too much about it at the end. 1 times 7 is 7. 4 times 3 is 12. Negative 7/12. Blapo. No big deal. Let's do one more example with a substitution property. Evaluate thingy-mabab. All right, so we're going to evaluate. This is example 3, yes? Example 3. Okay, example 3, we're going to evaluate one half AB if A equals 6/7, B equals negative 4/9. We want to write our answer in simplest form, okay? So, just like every other one of these problems, we're going to start by rewriting this with parentheses where the variables live. So 1 half, parentheses, parentheses. No big dealio. Then we're going to substitute this for A, 6/7, and that for B, negative 4/9. So we're going to do this first multiplication first. Sound like a good idea to y'all? Yes? Okay, good. I'm so happy for you. All right, so let's pre-reduce, shall we? 6 and 2 reduces. 6 divided by 2 is 3, and 2 divided by 2 is, erase this. That's going to look confusing if I don't. 2 divided by 2 is 1. So 3 times 1 is 3. And 1 times, what is that? Oh, that's leftover. Leftover of the box thing. I was trying to be clever and creative and wonderful and just kind of confused me. But it's okay. 1 times 7 is 7. That's something worth thinking about. Just throwing this out there. That is, as you're doing these problems, and any problems, it's a really good idea to kind of be checking as you go almost. Thinking about, does this make sense? So I was looking and thought, well, why is there a 1 there? I only canceled one thing. That doesn't make any sense. Why would it be a 1? And that's, I was thinking, oh, that's really cool. It's going to be 1 on the bottom. It's going to make our life super easy. But then I thought, why? That shouldn't be 1. And so I fixed it. I didn't even have to look at notes or anything. And so that's a skill that you can practice, is to kind of think while you're doing your math. I know that's kind of a strange thought to actually think while you're working, but it's really helpful. You guys can do that too. 3 and 9 reduces. 3 divided by 3 is 1. 9 divided by 3 is 3. Easy peasy, lemon squeezy, right? 1 times 4 is 4. 7 times 3 is 21. But it is a negative 4/21 because negative times a positive is a negative. That's really simple. That's it for multiplying fractions. Again, if you want to see an entire video, it's got some division of fractions in there too that'll tie into our next lesson. Entire video on pre-reducing, where I do a bunch of examples and some bigger ones and some crazier ones and all that kind of stuff. To get that pre-reducing really, really well, you can check out that link that is in the description or iCard or somewhere, and all of that. If you're one of my students, do your homework. I'll see you in class. Thanks for being here. If you're not one of my students, thanks for being here. Really appreciate you taking the time to watch, and hope this has been really helpful to you. Let us know in the comments if these have been useful to you, and if there's any other things you have, any other questions or topics that you'd like us to go through, and all of those things. If you want to see what else we're doing, you can check it out at emberlearninglabs.com. And it really helps us out be able to provide this course to you, at least the lectures, for free here if you hit that subscribe button and if you drop a like on this video. Thanks, guys. Have a great day. Bye-bye.